Welcome back to our Ubuntu server series. Today we're going to talk about file and print services. Now this is going to be a really fun nugget because we're going to mess with a bunch of different computers on our network. We're going to learn all about Samba for sharing files with Windows. We're going to learn about Netatalk for sharing files with Apple OS X machines or OS 8 and OS 9 machines if you're still running old school. We're going to learn about NFS, Network File System, for sharing files with other Linux or Unix systems on our network. And then we're going to finish off talking about CUPS, the Common Unix Printing System, for setting up a print server on your network, and more specifically in this nugget, how to reach the administration pages for our CUPS server. Let's get to the command line and get to business. And what are we going to start with? Samba. So we'll start out with Windows file sharing. Now I just wanted to make a note here that when you're setting up Windows file sharing, Samba is the daemon or the program that we use to do file sharing with Windows machines. Samba also does printer sharing, so you can use Windows native printer sharing. However, I'm not going to focus on that, and most people anymore don't necessarily focus on that because current Windows operating systems support non-Windows printers. So you can print to a printer that is shared by a standard CUPS server, Common Unix Printing System, or you can, connect to something shared by OS X. Windows printing has matured a lot, so you don't necessarily have to use the Windows native printer sharing anymore. So we're going to focus on file sharing. Now I wanted to mention version 4 of Samba, which is not stable, it's not out, it's not current, right? But version 4, which has been in development for a long time, and I'll be honest, some people are actually using it in production even though it's not stable, it will provide full AD service. So Active Directory, in version 4 of Samba, you'll be able to use Samba as an Active Directory server without any licensing fees. So the future is really cool as long as we can, keep going and then provide compatibility with Windows 2012, etc., etc. Right now, Samba does file sharing very, very well. Now, it can authenticate against an existing Active Directory server, but it doesn't need Active Directory. It can just use actually a multitude of authentication schemes. Samba is powerful and can use AD for authentication, even though until version 4 it can't provide Active Directory authentication, right? It doesn't act as the AD server. It can just authenticate off an existing AD server. But we're not going to touch AD at all. We're going to set up a simple file share using Samba and get you pointed in the right direction so that you can customize it to your particular needs. So let's go to the command line and install Samba. Okay, here we are on our workstation. Let's SSH into the server, and here we are on our server. To install, simply apt-get install Samba, and we'll get the Samba daemon installed. It's going to install a couple dependencies like Samba Common, that sort of a thing. So now it's installed. It was that easy. We've installed Samba. Samba's running. But in order to have it do things, now interestingly, by default, it actually does share out your printers using the Windows protocol. We don't have any printers installed, but I just think that's an interesting thing that Samba does by default. Kind of cool. But we're going to set up a very simple file share. So in the Samba directory, etc., Samba, you'll see there's a couple files. The one we want to edit is smb.conf. This is one of those files I just love when packages do this. They make a very, very thoroughly documented configuration file. I love that. Things like workgroup equals. Well, if you're a Windows person, the name of the workgroup is pretty simplistic. You're just naming the workgroup that your computer is going to belong to. We're going to leave it as the default workgroup. I think actually workgroup is what Windows defaults to as well. Server string is, it even tells us it's the equivalent of the NT description field. So for this case, it's going to be this %H will translate into the host name. So ours is going to be like CBT server Samba Ubuntu. It's just the description field basically. So most of the stuff by default is fine. And one thing I want to change while we're in here is authentication. Now, I talked about authentication in Samba having lots and lots of different options. Like you can authenticate from an Active Directory server, you can authenticate from local users, a local database of users. It's complicated because the password hash for Windows is different than the password hash for Unix, so there has to be like a translation table. But Samba can handle all of that stuff. It's pretty slick. For our very simplistic example here, we're going to say security equals share. And what that means is it's defined at per share. So we're going to set up a file share, and the security is going to just be based on what settings we put. This is probably not a good idea for a production server unless you're just at home and want to set up a common file share that everybody can connect to. Then this is how, it's a very, very simple way to provide a share that people don't even have to authenticate in order to get to. And we're going to actually set that share up. All of this other stuff, a lot of this has to do with the different authentication schemes. All the way down at the bottom of this file, you're going to see a bunch of different sections that start with bracketed names like this. These are all commented out, but these are talking about different shares. Like I said, printers by default are shared out, which is kind of cool. I just think that's kind of neat that they share out all of the printers installed automatically. But we're going to set up a new share. We'll actually do it right next to this CD-ROM share. Again, this is commented out, but we're going to create one here. And the name of the share we're going to have to put into brackets. So let's call it shared drive, close bracket. That's going to be the share name. So if you're a Windows person, the share name, that's the share name that we're going to be connecting to. Then we have to give it a path. Oh, let's just say we're going to create a folder in the MNT directory, and we're going to call it shared drive, just for simplicity's sake. So that's where the physical path on our local file structure is going to live. Browsable. This means if you're browsing the network as a Windows user, are you going to be able to see this, or are you going to have to explicitly know its share name? Well, we want it to be browsable. We want it to be super convenient for the users on our local network here. Guest OK. Yes, we want guest users. We don't want anybody to have to authenticate, right? Authentication isn't even going to be necessary. Read only. This is an option, but we want it to be no. I think by default read-only is yes, and we want it to be no because we want people to be able to dump anything in here. And then create mask. Now, create mask is a little complicated to explain, but it has to do with Unix umask, like what permissions files are created as. And we're going to, I think 0755 is a good way. That way, other people are going to be able to see files created. But since it's all going to be based on the permissions the folder has, since we're not really authenticating, it's not as big of a deal, but it's always nice to have a create mask so that files are created with the proper creation. Maybe you want files created so that nobody has access to them. This is the place that you would set that sort of thing. But create mask 0755, that's a good way to set things up by default. Okay, so we have our shared drive share set up with kind of the minimal amount of options in here, and we will save this file. So the only changes we've made so far is we changed security to share-based security, and then we set up that little stanza to make the file share. Now we actually have to go into the MNT folder. This is generally where you mount things, so my picking the MNT folder to create a share probably isn't the standard, isn't a great idea. Again, on a working file system, you might want to put that in a common place where the rest of your file shares are, but it's fine. As far as Samba is concerned, it doesn't care where you store the actual shares. So we're going to make a folder called shared drive. Is that what it was? Shared drive. I hope that's what it was. Let's see what it is. Actually, let's make it so everybody can read and write to it. 777 just means it's wide open. Anybody can read and write delete to anything in that folder. Let's see, all the read, write, execute permissions are all there. So shared drive is a wide open folder. Anybody should be able to connect to it. And the next thing to do is to test that. So we need to restart our Samba service. And there's actually two of them. The SMBD daemon is the actual file serving daemon. And then NMBD is the NetBIOS name server that actually announces the name of our server on the network. So we're going to restart both of those. And then let's go over to a Windows box to see if it worked. I happen to have a Windows 7 machine right here installed, waiting to try things out. So let's see, I'm not a Windows person really, but we'll just open up okay, we have a window open. Now, if we click on network, we should eventually see our server populated. Okay, we should see on here where our server eventually appears, but we can go directly to that address and see it's already found it. 168.1.80. So if we do that, now it's browsable, so we're going to see all of the shares available on our server. And there's shared drive, just like we did it. Double click, we're in here. Now let's see if we have permissions to create a folder. my cool stuff. I've created a folder on this Samba share. Now let's go back and see what that looks like on our server, right? So here we are back on our server. Let's look inside shared drive. Oh look, that folder we just made in Windows is now created on our server. Okay, so that's all there is to setting up Samba. Again, this is a very simplistic look at it. All we did is set up a share-based security single folder shared out on our network without authentication. Samba's much more powerful, but this gives you an idea of where the configuration files are and a good way to start. All right, so etc. Samba is the place to start. smb.conf is the configuration file. All right, let's move on to our next way of sharing files with other file system programs. Other operating systems, that's the word, doggone it. So let's move on to OS X. Now there's a daemon specifically meant for sharing with Apple computers, and the program is called Netatalk. Now to be honest, Netatalk was really more of a necessity back in the days before OS X, because OS X allows Apple computers to connect over NFS or over Samba, also over Apple Share, but it used to really be significant back when Apple Share worked in like OS 9 or OS 8. Now, so nowadays it's not quite as important for you to use Netatalk, but it is a native Apple Share type daemon, and if you have a strictly Apple environment, it might be the way to go, especially if you're trying to host home directories. Sometimes it works better if it's a native Apple Share sort of thing. Something important to note, as of Netatalk version 2, no longer will Netatalk honor symbolic links on your system. And this really bit me in the rear end a few years back, because on all of my the network with all of my Apple computers, I used to have a symbolic link in everybody's home directory that linked to a common shared folder. Problem was, when we went to version 2 of Netatalk, all of a sudden that symbolic link wasn't there at all, so I had to set up a new share and mount it separately, etc., etc. So this probably won't be an issue for most people, but just know that this changed in version 2 of Netatalk and has followed suit in version 3, that symbolic links on the underlying Linux operating system are not followed. Okay, one good thing, well, there's a lot of good things, but one kind of cool thing about Netatalk is it's much easier to set up authentication. It uses the underlying PAM, pluggable authentication modules. It uses this in order to authenticate. So there's really nothing you have to do to set up user authentication. And we're going to set up and install Netatalk so quickly that it'll just blow your mind. Well, you'll think, wow, that was easy. So let's go set up Apple sharing on our server, and then we'll almost be done with the file sharing part. So let's open up our terminal to our server. And the command for installing is just like with Samba, apt-get install, but this time we're going to do Netatalk. We'll hit enter, let it install. And out of the box, now this is actually pretty cool, out of the box, Netatalk on Ubuntu 12.04 actually serves out home directories without any configuration. But since it works so well, we're actually going to go into the etc. Netatalk folder. I just want to show you some things. Now there are options as far as different authentication schemes and all sorts of stuff that you can configure, including print sharing if you want to use the Apple Talk version of print sharing, which isn't really needed at all anymore, but is still possible if you want to do. There are a bunch of settings that you can tweak in here, but the file that we're going to look at isn't necessarily clearly the one we want to look at, but it's applevolumes.default. So applevolumes.default is where the shares are defined. There are a bunch of comments in here. Some of this is going to be confusing, I won't lie, but some of it makes more sense if you are an old school Apple Share administrator. All right, some of those will make a lot more sense. But at the very end, you'll see where the shares are defined. Remember I said out of the box it supports home directory shares? Well, it does. So the tilde represents your home, like every user's home directory. So tilde slash and the name is mounted to home directory. We'll actually see that, but I also want to add another one. So let's add mount shared drive, and we'll name it shared drive in quotes. We only need quotes because it's two different words. We don't want it to be mistaken for like two different commands. So if there's a space in the name, make sure to put it in quotes. And that's all we have to do. So this is by default already there. By default, all users have access to their home directories. And then we've created this one single share called shared drive. As far as permissions go, since we're actually logging in as a user, this is going to follow the permissions on the underlying Linux file system, which is just really slick and really easy to manage. So let's save this. We're going to restart the service Netatalk. There's only one that we have to restart here, and it actually does a couple in the service restart process. So this has been restarted. We should have 2 shares available now. Let's switch over to OS X. All right, here we are in Mac OS X. Apparently there's an update. I'm not going to install that right now. But let's go to Go, Connect to Server, and then AFP. We want to make sure that it connects to our server with AFP, or Apple File Protocol, as opposed to Samba, because we have both AFP and SMB installed on the server now, right? We just installed both. So we want AFP, // we'll put the name of the server, or the address of the server. This would also work with domain names, but DNS on our closed test system can be wonky, right? We don't remember exactly where we left the state of our DNS server, etc. So I just want to put the IP address in there just to make sure we're connecting to the right server. So put this in here. I could specify shared drive and it would connect after authenticating, but I don't want to do that. If we just leave this blank, it'll allow us to browse once we click connect. So it obviously found the server because it's prompting us for our password. This is just an Apple thing. It's always been like this. It will either use username or your full name. It detected my full name on the system, and it's going to let me log in. I'll just leave that there. I could change this to S Powers, but we'll just leave it at Sean Powers because that's my name on the other server as well. Put in my password, click connect, and then we have 2 different options. Look at that. We have our home directory and we have a shared drive. If we hold down Shift, we can actually select both of them, and it should mount those on our desktop. So just so that they display on our desktop here. This is just a OS X thing. It's a whole different series, I suppose, tweaking OS X. But here they are. This is our home directory. These are the things that you may recall are on our home directory on our server. Remember, we were talking about these UDEV rules back in the day, and here's default interfaces. I had never erased anything out of our home directory, so this is stuff in our home directory. And then this is that My Cool Stuff folder we made. So we can make a new one. And this one's called My Cool OS X Stuff. Alright, hopefully that makes sense. You can see that it's working just fine. We can do stuff in our home folder if we want. Home folder thingy. And if we want to eject these, we can eject them, and they're disconnected. See what we did back on our server. Let's switch over to our server here. In shared drive, now we have a couple things here. So this is My Cool OS X Stuff, right? I made this. Here's my user group. Sean Powers. This network trash folder and temporary files, these are files that are created when you mount a share with OS X. It handles trash folders and then temporary items a little bit differently. So they're not going to show when, on our mount over in OS X. However, it actually creates these files to work behind the scenes. And then here is that same file that we created in Samba, My Cool Stuff. All right. Why does it say nobody and no group here? This is because if you remember, we didn't actually authenticate with Samba. Do you remember we just connected with guest privileges? And so it created it with nobody, no group. So nobody actually, this isn't owned by a specific person. The only security we've done is share level security, and it allowed us to write to there. So those are all of our files. If we go back to our main directory, you'll see home folder thingy that I created, and here are all the other things that we saw mounted in OS X. So that's how you share with Apple protocol. I personally think it's even simpler than Samba. It works really, really well. It's pretty slick. It's fast. It's efficient. It's pretty neat. And it's called Netatalk. Let's go back and get the next file sharing, the last file sharing method we're going to look at covered, and then we'll move on to print sharing. The last protocol we're going to look at is NFS. Now, NFS stands for Network File System, and there are 2 current versions, if you will. Version 3 and version 4 are both in use, but they have kind of vastly different configurations. It's a complex endeavor that I go way more into detail in the Linux in the Real World series. But conceptually, they work the same. Basically, it's the way that you share from one Linux server to another. Usually, it can be used like from Linux to OS 10. I don't think, actually, Windows may support NFS now. That's possible. But generally, it's Linux to Linux or Unix to Linux, mounting different shared folders over NFS so that it acts like a local file system. Okay. The big difference, just so you know a little bit, version 4 of NFS supports Kerberos. Historically, version 3 and previous of NFS doesn't have a whole lot of security. There's no authentication. So if somebody could fake an IP or steal an IP address, they may have access to files and folders, and that can be a scary thing. So version 4 adds some much needed security, but version 3, if it's in a closed network or at home, it's usually just fine. And conceptually, they're exactly the same. So what we set up today is going to be valid whether you're using 3 or 4. All right. First thing we have to do is configure NFS, and then we will test out a mount to see how it works. Now, I don't know about you, but I actually really enjoyed this nugget, setting this nugget up. I love setting up file shares and watching networks work in real life, and I just think it's cool stuff. So this last protocol we're going to look at is, again, like I said, NFS, and we install it the same way that we install the other two protocols, except this one is named a little bit different. So when you install on the server the NFS server daemon, it's NFS-kernel-server. And why kernel server? Well, it just means that the NFS sharing is handled at the kernel level as opposed to user space. But you actually have to use the format correctly here. Sudo apt-get install NFS kernel server. It's going to install this process. And what I was saying is the kernel server, that's really the only option we have, but this just means that it handles all of the network negotiation at the kernel level instead of at the user level, and it makes it a little bit more efficient. Okay, so anyway, NFS kernel server is the name of the package that we need to install, and bam, our NFS server is running. It's all in place, but it doesn't currently have any shares set up. So we're going to do that. And the file that we need to edit, in this case, is etc exports. So it's not etc NFS, it's etc exports. These are the file systems that we're going to export over NFS. So edit this file, and you see, I love when they add documentation to configuration files. It's just awesome, right? So if you look here where we talk about, this is an example for NFS version 2 or 3. By the way, the server will support both. So you don't have to worry about what version of a server you've installed. It will allow you to do NFS version 3 and NFS version 4. And you can see that the format's a little different. See here it's talking about Kerberos. We're going to set something up just like this. All right, this is going to work. It's going to be an NFS version 3 sort of share that we set up. So what we type is the share that we want to share, like the folder that we share out or export to the rest of the network. And we're going to use the same one. Mount shared drive. And then we say who is going to have access to it. Now I want my entire subnet to have access to this share. So I'm going to say 192.168.1.0/24. Now, if you've ever taken any Cisco classes from CBT Nuggets or you're familiar with IP subnetting, you're going to know that this means every computer in my network that has a 192.168.1.something address is going to be included in this. Okay, this is just defining this entire network, the entire 192.168.1 network. Okay, and then in parentheses we write the options. I'm just going to say read write, so it gives it the read write option. It'll have everything else by default, and that's really all we need in here. So we'll hit escape, we'll save this file, sudo service nfs kernel server restart, so that it loads that file. And it gives us a couple warnings that says neither subtree check nor no subtree check were specified, and it's going to use the default no subtree check. Again, these are some complex things that we talk about with NFS that you may want to tweak someday. However, for us, that's perfectly fine for it to use the default. And now, well, we've set up a share, but how are we going to test to see if it works? Lucky for us, we happen to be on a Linux machine here, right? Remember, this window is a window into our server. But if I start up a regular terminal, I'm on our local Ubuntu box here. So we're going to install something here, sudo apt-get install nfs client. And then we're just going to simply install, oh, and I've already installed it. It's NFS Common. I'm sorry, the name must have changed to NFS Common as opposed to NFS Client. And that's fine. We have the latest version installed, so we're good. Now we can actually mount a folder. So let's see what's in our folder here. We have a couple things here. Let's see if this folder test has anything in it. Test. Nope, there's nothing in test. So test is, let's make sure. ls-a test, make sure there's no hidden files. Okay, no, there's nothing inside this folder called test. So we're going to mount our remote server. Sudo mount -t for type, nfs. The remote server is going to be 192.168.1.80. Remember, that's the IP address of our server. Colon, and then what share? We're going to do mount shared drive. You actually type the name of the exported folder. There's no special like rename of it. We don't have a share name like we do in Samba or in Netatalk. We actually just type out the exported folder name. And then the last argument is where do we want it to mount? Well, we'll just put it right here in this folder. So type all that, hit enter. We get no response. However, now if we look in test, we're going to see all that familiar stuff. My cool OS 10 stuff, my cool stuff. And it is going to show us these special Netatalk files that it created. Netatalk would hide it from our OS 10 computer, but we're sharing from Linux computer to Linux computer. It's going to show us everything that's in there. If we actually type mount, it'll show us that it's mounted. See, 192.168.80 shared drive is mounted on home S-Powers test. Type NFS, it actually mounted it as version 4. Again, there's not a whole lot of difference between version 4 and version 3 unless you're doing lots of multiple shares, and then it gets a little complex. But just know that we have successfully set up NFS. We can mount this on any server that is in the 192.168.1 subnet because of the way that we've set up our etc exports file. We've given permission to mount to this on the computer that we're mounting. But anyway, that's an NFS mount. We've done that. We're almost finished. The only thing left to do is talk about print sharing. And I just want to show you a way that you can manage your printing system on your server easily from a remote computer. Because by default, it's not terribly easy to do that. So let's look at the CUPS Common Unix printing system really quickly, and then we'll come back to our server here and set that up. So the print server utilized in Linux is called CUPS, and it stands for Common Unix Printing System. Now there was LP or LPR printing years and years ago, but this has been the standard for a long time and will continue to be the standard for the foreseeable future. Again, CUPS stands for Common Unix Printing System. Interesting bit of trivia that not a lot of people know is that CUPS is actually software owned by Apple, oddly enough. Thankfully, it's open and we're allowed to use it in other operating systems, but Apple actually does own it. Now what CUPS does, it's the way that Linux and also OS 10, as you can probably guess, computers print to local computers and network printers, but also it allows, and this is where the server install of it makes sense, it allows for sharing of printers from one central server. Now in a small environment that doesn't make a whole lot of sense. Everybody would just point to the local printer. However, if you have tons and tons of printers in your environment, it's really nice to have a central place that people go through for printing. So if a print job gets stuck in queue, you can go to one single place to delete it instead of trying to figure out what computer is, sending a bogus print job, etc., etc., etc. You can also control authentication and things like that from one central place. Unfortunately, by default, for security reasons, it's not a dumb decision, but by default, CUPS blocks external access. So if you install it on a server, you actually, without any GUI tools, configuring it can be rather difficult. So that's what I want to show you today. We'll install CUPS, the print server system, and then I'll show you how to open it up so that you can use the web-based administration tool from another computer. Now, I'm going to put in parentheses here SSH, because we're going to learn some awesome tricks with SSH in a couple nuggets from now. And one of the things that we can do with SSH is tunnel traffic, so we don't have to open up this external access in order to administer CUPS. However, it's nice to be able to know where to go to configure this if you don't have the ability to actually tunnel with SSH. Like say you're administering it from a Windows computer. Well, then you can actually access it with a web browser by unblocking the external access to the CUP server. Also, if you don't have external access unblocked, you're not going to be able to print to it from any other computers, right? So this is important stuff. Let's install CUPS and configure it, and then we'll wrap this nugget up. Okay, let's go into our server, and just like everything else, we're going to apt-get install our print server, and it's simply called CUPS. So apt-get install CUPS. There's a whole bunch of dependencies, but because of the beauty of apt-get and the deb package management system, it's just going to get all of the dependencies and install them all for us. Don't you just love apt-get now? Anyway, CUPS is now downloaded and installed, and unfortunately, we won't be able to get to the administration pages from anywhere but this local computer. So we're actually going to change that. We're going to go into etc. CUPS, and we're going to edit the cupsd.conf file. So etc. cupsd for daemon.conf. We're going to edit that file, and we're going to change a couple things. One is listen. Now, we've been talking about Unix terminology for quite a while, so hopefully this is something you can already guess what we're going to do. By default, it's told listen only on localhost port 631. We want it to listen on all of the IP addresses, including the public IP address that we have, 192.168.1.80. So the cool way that we can go about doing that, now we could just put 192.168.1.80, but then it wouldn't listen on localhost, and that's not what we want either. So the way that in Linux that you can tell it to listen on all of its IP addresses is to put 0.0.0.0. That's just some, cool shorthand or a cool trick that now you know that if you're telling it to listen on an IP address, if you put all zeros, that means listen on all IP addresses. Okay? The other thing that we want to configure down here is restrictions. By default, we have a lot of restrictions in place. It's restricting access to the server, the root location of the web server here. So we're going to add in each of these locations allow from 192.168.1.star for everything in here. Now I know the terminology is different in different places. Like in NFS we used 192.168.1.0/24. Here we're doing 192.168.1.star. Some programs just like the format in different ways, and if you get the format wrong, the School of Hard Knocks is sometimes the best way to learn that. If you get an error when you restart, well, then you might have to Google it, or you might just have to remember these nuggets that we've shared together so that you know exactly what format to use. And lastly, down here, we're going to add... Alright, so we're allowing the admin pages, the admin configuration, and the root of the web-based administration pages of CUPS to be accessed remotely. Okay, so that's what we've done. And CUPS is now listening on all IP addresses. So we'll save this file. We'll restart the CUPS daemon. And that's it. And now, remember, this is on our server. This is on our workstation. We're going to open up a web browser on our workstation. And now we should be able, let me make this a little bigger. We should be able to go to 192.168.1.80. Do you remember the port? CUPS is on port 631. That's just a standard. It always runs on port 631. So hit enter, and here we go. The CUPS server is now accessible from a remote computer, and we can configure it. And remember I said that it's from Apple? Sure enough, developed by Apple. How cool is that? Anyway, here we are. We're logged in. Now if we want to actually administer things, we click on administration, and we can see these. However, we're going to get prompted for authorization once we actually try to make some changes. So let's do some things here. Let's say we want to show all the printers shared on other systems, and we want to share printers connect to this system. We'll want to share them on the internet or on the entire network. And we already have checked allow remote administration. So if we click change settings, it's going to say you have to be doing this over HTTPS. And it redirects us, and then we have to actually accept the self-signed certificate. By now, this sort of a process should make sense. So now we're at the same place, but you'll see we're using SSL, right? We're using HTTPS, still port 631, so it's the same port, But here we are, and now if we try to make some changes in this, it's going to ask us for our login and password. Now on some Linux systems this has to be the root user, but thankfully Ubuntu has us set up in the system group so that we have sudo access. Well, this also means that our user has access to manage the CUPS system. We've made those changes. It's restarting the CUPS system just like we did back over here with the service CUPS restart. It just did that with that job. And now we can completely administer this server. We can add a printer if we want all over the web page. You've added printers on systems before, but CUPS supports a wide variety of types of printers. So let's add, for example, an HP. This is just printer lingo here. The HP LaserJet printers will normally listen on port 9100. They give you an example down here, socket hostname 9100. So if I had an HP laser printer at 192.168.1.100, I could put that information in there, click continue, type all the stuff about it. I can say, do I want it to be a shared printer or not? Put a bunch of information in it, click continue. It's going to say, okay, what kind of printer is it? I probably didn't need to go through this entire setup. I'm just going to pick one here. I actually don't have a LaserJet printer, but let's say it's a HP LaserJet 5100. Add the printer. You can set default options. And so now if we look over in printers, sure enough, there is the printer that I've installed. And if you remember, I actually shared it, so it's shared on the network. We can modify the printer. Basically, if you've configured CUPS on a computer before, this is all going to look familiar. But this is how to manage the print server on our remote server now that we've allowed ourselves access to it. All right, let's make sure we got everything covered. But this has been a fun nugget, and hopefully it's been useful for you as well. Back here at our opening slide, I want to make sure that I did everything I promised. We set up Samba, we installed it, we configured it, we tested it on a Windows computer, and we were able to use that share that we created. We set up Netatalk, and we tested it on an OS 10 machine. We were able to mount those shares and mount our home directory. We set up NFS, shared it from our server to our Linux workstation. That worked. And then we configured CUPS so that it can be remotely administered from a web browser on any computer in our network. So we did it. I hope that this has been informative for you, and I would like to thank you for viewing.